Hello everyone, welcome to my YouTube channel. I'm Kaushik here once again. Today we will learn about the row reduction techniques in matrix. And normally there are two, apart from the Gaussian elimination process, there are two other techniques which are very popular and important. One is row echelon form. This is, I will say, a good technique. This one, reduced row epsilon form, is kind of the best technique. Okay, and basic rules which you have to remember, that is very important. One, if somebody is giving you a matrix, then what are the things you can do? You can rescale a row. This operation is allowed. You can add a multiple of one row to another, and the third one is swap, swap, swap to rows. These are the three operations are allowed, and in today's video I will explain how using these three operations you can convert any matrix you can convert into either row epsilon form REF, or you can convert into RREF. Okay, so okay, our goal is basically put a matrix into row epsilon form or reduced row epsilon form. It's very important to understand that what are the properties it has to satisfy to call it row epsilon form. First of all, like in my last class, I already mentioned that you can do this kind of operation, add a multiple of one row to another, rescale a row, swap two rows, all these things are possible. But how this matrix will look like so that you can say, okay, this is the row epsilon form. Something is, some of the rows have nothing but zero. This is possible. These things are possible, but in that case that row has to be the last row. So that's mean if there is such possible, you have to swipe it and make it the last row. So this is very important, that if there is such a row which has only zeros, that has to be the last row. Second property, every other row has non-zero entry. So every other row has a non-zero entry. That's mean all these rows should have a non-zero entry. First non-zero entry is called pivot. This is not a property, but this is just for your understanding that first non-zero entry of a row is called the pivot, and that can be any value for row epsilon form. And each pivot should right of the previous pivot. What does it mean? If you check, like my second pivot is on the right, third pivot is the right of this one, fourth pivot is right of this one, so like this. And what are the properties for reduced row epsilon form? That is, it should satisfy all the row epsilon form. That's mean it should satisfy all these A, B, C, D, all these conditions. Along with that, there are two more other important factors. That is, um, rescale the rows so that the pivots are all equal to 1. So the basic difference is here the pivots can be any non-zero value, but here all the pivots should be 1. And above each pivot, it has to be all zeros. So like pivot here, this value should be 0. Pivot here, all these should be 0. Pivot here, all these 3 should be 0. So these are the 6 properties has to satisfy for reduced row epsilon form. Okay, and in the next class we'll see basically how to make any matrix into row reduced row epsilon form, because that is the best option. um, okay, so let's start with one example. Suppose we have a matrix like this, and if you have already following my class, you know that we can do this kind of operation with either rescale, add a multiple of one row to another, and like this. Okay, so here first thing, then we want to make these elements to be 0. This is our first kind of target. So what we can do, we can multiply this by 4, and then we can just add this line and this second line. So what does it mean? It will be 1, 2, 3, 4, but this row will start with now 0, and this is now -8, and if you are adding 5, then -3, -6, and then this will be -9. And now on this operation we are again multiplying it by -6, suppose, and then we are adding it. So now this will be 0, and this is -12 and 7, so that's mean -5. This is -18, 6, so -8, so -10, and the last one is -15. Okay, now what is our next goal? Our next goal in this case is basically make sure that all the pivot elements are basically 1, right? So what we can do, we can simply divide the second line by 3. So what will happen in this case, it will be 1, 2, 3, 4, and this will be 0, 1, 2, 3, because we are dividing it by -3, and same thing will happen here also. We are dividing it by -5, so 1, 2, 3. Okay, and simply on the last, what we can do, um, we can, because we have to make sure that these all are 0. Okay, so if we just subtract this line from this line, then this will be 1, 2, 3, 4, 0, 1, 2, 3, and this one is actually all in the 0th form. But we are missing one point here, that is we have to make sure that our last condition, which is we have to make sure that this is also 0, right? This has to be 0 also, then only it will be complete. So for that, what we can do, we can simply multiply it with -2. We can multiply it with -2, the second row, and then if you just add it, so 1 will be there like that, but this will be 0, and this is minus 4 plus 3, so minus 1. This is minus 6 plus 4, so minus 2. And this one will be 0, 1, 2, 3, 0, 0, 0, 0. So now this is actually in the RREF of matrix A. This is the form. Okay, so this is the matrix and this is the RREF form of this one. And if you now try to recap actually whatever we mentioned, whether it's matching or not. So look, all the pivot elements are 1. So all the pivot elements are 1. In this case, let me just take another color. So all the pivot elements are 1. Last row has all the zeros. We cannot keep this here and there. Last row can be possible for all the zeros, and all the elements above the pivot should be 0. So this is the simple way to convert it actually, and it's a very useful technique. And when we learn more about the vector space, we'll definitely cover more on thing. But right now, this is the process, this is the steps, and everything I will share into my GitHub page, so you will have a note of all these things, and you can basically follow with me. If you like my channel, please don't forget to subscribe it and hit the like button, and I'll produce this kind of lot more videos for you so that it will be helpful. I'll provide my email ID. By chance, if you need to contact me, you can email me. We can work together, learn together, grow together. Thank you so much. Have a nice day.